Good morning to you all. Already we know that the poles, any one of the pole is on the right hand side of the S-plane, then the system is said to be unstable. We know. Already we have seen for first order, second order, up to third order we have seen. We know how to find the poles of first order, second order, up to third order. But beyond that, it's very difficult to find the roots of denominator, that is poles of the system. That's why it's difficult to say the location of poles. So there is a procedure to find the location of poles, whether it is on the right hand side or left hand side or on the j omega axis. For that, there is a criterion called Routh-Hurwitz criterion. Let us see that. Routh-Hurwitz criterion says that the first column of Routh array can say the location of poles. If any of the first column elements, any of the first column elements have sign change, then the number of poles on the right hand side equal to number of sign changes in the first column of Routh array. Routh array is an array of numbers formed from the characteristic polynomial. Suppose it is like matrix, the first column of Routh array doesn't have any sign change, means then the system is said to be stable. Now we will see. Routh array. Let us form the Routh array. Let f of s, that is characteristic polynomial, equal to s power n, a n s power n plus a n minus 1, s power n minus 1 plus a n minus 2, s power n minus 2 plus etc. plus a1 s power 1 plus a naught. P a nth order characteristic polynomial, or we can say that denominator polynomial of a open loop system or closed loop system. If you find for open loop system, then it is called open loop stable system. If you find for closed loop system, if you find the closed loop poles for a closed loop system, then it is called closed loop stable system. This is the given characteristic polynomial or denominator polynomial. It is nth order. Nth order. Because s power 5, that's why nth order. How many poles will be there? N number of poles will be there. To find whether the poles are on the right hand side or not, we have to form Routh array. Routh array. How to form Routh array? The highest degree we have to write s power n, s power n minus 1, s power n minus 2, s power n minus 3, etc. s power 0, s power 1. S power n means we have to write a n here. Next coefficient a n minus 1. The next coefficient is a n minus 2, a n minus 3, etc. A naught. So if it ends here, then we can put a 0 here. Otherwise, sometimes it may end like this, a1, a naught like this. It depends upon number of even number of coefficients, means it will end like this, a1, a naught. Odd number of coefficients means it will end like this. So from the polynomial, now we can form two rows. First row is an minus 2, etc. a naught. Second row is an minus 1, an minus 3, etc. So this is first row of Routh array. This is second row of Routh array. Now we have to form third row, that is bn minus 1, etc. etc. Up to b1 it will come. One short of the polynomial. So what is bn? Bn equal to an minus 1 multiplied by an minus 2 minus an multiplied by an minus 3 whole divided by an minus 1. This we have to remember this way. We have to multiply these two minus product of these two divided by this. That is bn. What is bn minus 1? Bn minus 1 equal to, again we have to consider an minus 1. Here what will be the number? An minus 4. Here an minus 5. So what is bn minus 1? Bn minus 1 equal to an multiplied by, an minus 1, same element, n minus 1 multiplied by an minus 4 minus an multiplied by an minus 5 divided by an minus 1. That is bn minus 1. Here, how we found bn? We are taking these four elements and we have to multiply second row first column element with the second column first element minus first column first element multiplied by second column second element divided by an minus 1. How we will find the determinant? Suppose I am having a matrix 1, 2, 3, 4. For that, how we will find a determinant? 1 multiplied by 4 minus 3 multiplied by 2. Here we are doing in the opposite way. We are multiplying 3 multiplied by 2 minus 1 multiplied by 4 divided by 3. Just opposite to determinant. So how to find the next element? Bn minus 2, that is equal to again an minus 1. The same element we have to take. Next element is an minus 6. Here an minus 7 multiplied by an minus 6 minus an multiplied by an minus 7 whole divided by an minus 1, etc. You will get, suppose here in the first row, 8 elements are there, means here in the third row you will get only 7 elements. Here suppose 7 elements are there, means here you will get 6 elements, like that. One short of first row you will get. Then next row how to form? Cn minus 1, etc. C2, up to C2 it will come. How to find Cn? Cn equal to, we have to take second row and third row we have to take. Just now we found the third row. To find fourth row, this is fourth row. This is first row. Second row. Third row. To find third row, we used first row and second row. To find fourth row, we have to use second row and third row. Same procedure. Cn equal to Bn multiplied by an minus 3 minus an minus 1 multiplied by bn minus 1. Bn minus 1 divided by bn. That's all. The same way. So to find Cn, what we have to do is En multiplied by an minus 3 minus an minus 1 multiplied by bn minus 1 divided by bn. That way we can find up to s power 0. S power 0. Then what we have to do is, we have to check, is there any sign change in the first column of Routh-Array? If no sign change in the first column of Routh-Array, then the system has all poles in the left hand side of S plane and stable, otherwise unstable.